Okay, here we go on lesson 2, radical arithmetic. Again, you can see some more examples and explanations if you're having any trouble in the textbook on page 163 to 167. They go through pretty much everything I'm talking about here. At the top, I have our definitions from lesson 1 again. Remember, radical is another name for that square root symbol. The radicand is the number underneath it. An entire radical is when there's an invisible 1 out front. The coefficient is 1. A mixed radical is when the number out front is something other than 1. And the most important thing for today are like radicals. Like radicals have the same radicand, or the same number underneath the radical symbol. So why is that important for today? It's important because of this rule right here. This rule says if I have the same number or same value, same variable, same term underneath the radical, I can add the coefficients. So we're going to walk through a few examples here and show you how we can do some of these questions. All right, so let's start on these first couple guys here. All right, now, obviously 12 and 27 here are not like, but let's use the skills we learned from lesson 1 to simplify these. So 12, let's prime factorize it. 12 divided by 2 is 6. 6 divided by 2 is 3. So I can break 12 down into 2 times 2 times 3, all prime numbers. 27, same thing. What can we divide that by? Well, 2 won't work, but how about 3? 27 divided by 3 is 9. 9 divided by 3 is 3. So I can break this down into 3 times 3 times 3. Now, from lesson 1, remember, if we have a pair, like 2's in the first and a pair of 3's in the second one, we're going to get rid of them and just write one of that number out front. All right, so 2 root 3 is what we have, and this one will be 3 root 3. Now, notice how they have the same radicand, the same number underneath the square root symbol. That allows me to add the coefficient out front. So I have 2 root 3's plus 3 root 3's. Altogether, I have 5 root 3's. All right, let's check out another one. This next example looks a little more complex. It's really just the same thing with a few extra numbers. All right, so let's break these down. That 8 right there. Well, 8 can be broken down into 2 times 2 times 2. Sorry, a little bit sloppy there. The 3 can't be broken down, so we're just going to leave that as 2 root 3. 75. Well, let's start dividing by prime numbers. 75 you can definitely divide by 5. Right? 75 divided by 5 gives you 15. 15 I can divide by 5 again, which leaves me with 3. So 75 I can break down to 5 times 5 times 3. And finally 50. Well, 50 is even, so I can divide that by 2, which gives me 25. And then 25 you can break down to 5 times 5. All right. So let's find our pairs. Obviously we have a pair of 2's in the first one, a pair of 5's over here, and a pair of 5's over here. All right, so we're going to take those out, and this is going to be now 3 times 2, right? Bring that out, because again, why are we taking out only one and getting rid of both? Because 2 times 2 is 4, and the square root of 4 is 2. All right, and we're left with a 2 there. This one can't be simplified, so we'll just leave them. This one, we got a pair of 5's. Let's take out a 5 and get rid of those 5's. All right, and finally, we got a pair of 5's here. Let's take that out. And we're left with square root 2. All right, let's simplify the numbers out front. 3 times 2 is 6. All right, 2 times 5 is 10. And 4 times 5 is 20. All right, so we do have some pairs of like radicals, the root 2 here and the root 2 here. So we can add those numbers in front, the coefficients. 6 root 2 plus 20 root 2 is 26 root 2. And then look at our root 3's. We have 2 root 3 minus 10 root 3, so 2 minus 10 is negative 8 root 3. Now we can't simplify this anymore because these are unlike radicals, just like unlike terms. It's the same idea. Oops, I'm writing terms, but that's true too, or radicals. All right, so that's as simplified as that one can get. Okay, moving down the page a little bit more, let's do some multiplication of radicals. So what does the rule say right over here? It says that if you're multiplying, and we did some multiplying in the last unit, you just multiply the numbers out front and multiply the numbers underneath the radicals. So A and B multiply, and the X and the Y would multiply. So if I'm doing something like this first one here, okay, so we're going to multiply the 5 root 2 by each of the radicals underneath. So it's just like before, it's just we got to distribute using the distributive property or the distributive law. So multiply the numbers out front. 5 times 2 is 10. Multiply the numbers underneath the radical. 2 times 3 is 6. All right, go to your next one. 5 times, there's an invisible 1 out front, so 5 times 1 is just 5. And 2 times 8 is 16. Now, you can write it as 16, which is, just going to be the square root of 16 is 4. Or you could prime factorize it, but 16 is so easy. Square root of 16 is just 4. And we can clean that up a little bit and make that 20. Now, there's nothing else we can do here. We're done. We're not factoring. We're just leaving it as is. We can't subtract these. They're unlike, so we're done. Let's check out this next one. This next one looks very similar. It's just a little more, a couple more steps. So we need to multiply 2 root 3 by root 3. All right, so 2 times the invisible 1 out front is just 2. 3 times 3 is 9. So obviously, you know what? I'm going to finish some of these up right away. That gives me 2 times 3. Square root of 9 is 3, which gives me 6. All right, let's do the next one. 2 times negative 1. Not a lot we can do there. 2 times 1 is just 2 and root 3. That's that. All right, let's go to the next one here. Root 3 times root 18. All right, so both of those numbers can be simplified. They can be broken down a little bit further. So instead of going 3 times 18 and making it bigger, I'm going to factorize 18 to try and make it smaller. So 18 can be broken down to 2 times 9, and 9 can be broken down to 3 times 3. All right. So we got a pair of numbers there. So let me just drop these steps down a little bit because there's nothing I can do with this one yet. So we'll just leave it alone. This one here, we have a pair of 3's, right? So we can take out that pair and just write it as 3 out front. And 3 times 2 is 6. All right, so that's as simple as that one can get. And let's multiply the last one here. 3 times negative 2. Now, those are both prime numbers. We're not going to be able to simplify it anymore. So let's just go 3 times 2 is 6. And there's nothing else we can do with that. All right, now we get down to the end and we say, well, where are our like radicals? There's nobody that's like to the 6. This one isn't like to anyone. These are the only 2 like radicals. And don't forget there's an invisible 1 in front of that 6. So when we subtract it, let's just go and finish these guys here first. We have a 6 minus 2 root 3. These two, we can go 3 root 6 minus 1 root 6 gives me 2 root 6. And there's nothing else we can do with this to simplify it. That's as simple as it gets. All right, moving down the page a little bit. Let me just scoot this down a bit. All right. Let's multiply some more. Now this one, we have to multiply a binomial by a binomial. So we have to take the first term and multiply it by each of these. So let's start with 5 root 7 times root 7. That gives me 5 root 7 times 7, right? Which is 49. But we could just skip ahead and say, well, we know that the square root of 7 times 7 is just 7. 5 times 7, 35. All right, let's go to the next one. 5 root 7 times 4 root 3. Well, 5 times 4 is 20. 7 and 3 are both prime numbers. I can't break them down anymore, so I'm just going to multiply them and make them 21. All right, let's go to the next one here. Negative 2 root 3 times 7. So negative 2 times the invisible 1 out front gives me negative 2. And 3 times 7, again, are both prime numbers. Can't simplify those any farther. Gives me 21. And the final multiplication, negative 2 root 3 times 4 root 3. Well, negative 2 times 4 is negative 8. Root 3 times root 3 is the square root of 9, which is just 3. So what can we clean up here? Well, in the middle, 20 minus 2, those are both like radicals because they both have square root of 21. So we can subtract them and add them here. And 20 minus 2 is 18. Root 21, I'm just going to move that down a step. And the 8 times the square root of 3 times 3, it's the same as square root of 9. So it's just 8 times 3, which gives me 24. And to finish it up, the 35 and the negative 24 are like, so we can subtract those. 35 minus 24 is 11, plus 18 root 21. And there's our final answer. Now, you could switch the order of these, and you might be thinking about it in the previous ones, like what if you wrote your answer like this? It's the same thing, right? The same 2 terms, just written in different order. Okay? All right, final one. This is really more of the same thing, but this is a test favorite, this one here. So watch what happens. Notice how they're the same 2 terms, but one's a minus and one's a plus. This is a difference of squares, or at least a similar pattern to the difference of squares pattern, I should say. All right, so it is a difference of squares. Okay, so if I multiply the 3 times 3, that gives me 9. 3 times positive 2 root 5. Well, 3 times 2 is 6 root 5. Let's go negative root 2 times 3, negative 2 root 5 times 3, which gives me negative 6 root 5. And our final one is going to be negative 2 root 5 times positive 2 root 5. So let's be careful. Negative 2 times positive 2 gives me negative 4. And root 5 times root 5 gives me the square root of 25, which is obviously just 5. So we can clean this up a lot. These two in the middle are going to cancel. They make 0. They're the same term, but one's positive, one's negative, so they cancel out. And what we're left with is 4 times 5. And that's 9 minus 20, which gives us negative 11. So the same thing as the previous one, it's multiplying binomials, but this one's a difference of squares pattern where the terms will cancel out in the middle and you end up with a single term in the end. All right, let's go down the page and look at the final examples for this lesson. And that's going to be division. Okay, dividing radicals. Here's our rule right here. It's the same as multiplication. If you're dividing, you can divide the terms out front and divide the terms under the radical. And there's a few different ways you could really play around with these questions to simplify them. So there's sometimes more than one pathway. Let's start with an easy one. Square root of 76 divided by 2. Well, I could just write that like this. 76 divided by 2. Okay, and 76 divided by 2 is 38. Now, if you want to double check, can you prime factorize 38? The answer is no, but let's just show why. If you have 38 and you divide it by, 38. All right, there we go. And you divide that by 2, you get 19, right? So that's as far as you could break 38 down to. 38 is equal to 2 times 19. Nothing else you can do with that. So this is as simple as it gets. So we're just going to leave it as the square root of 38. Just a basic starter example. All right, let's look at the next one here. Okay, the numbers out front divide evenly. So 12 divided by 4 is 3. And then same thing. These numbers under the square root can be divided. 42 divided by 6 is 7. Again, nothing we can simplify underneath the square root symbol. Pretty easy. Now here's where things get a little wonky. The 4 and the 3 don't divide, and the 90 and the 72 don't divide. So instead of dividing them like that, why don't we factorize the numbers underneath the radical symbols? All right, so let's try to break 90 down. Okay, so if I have 90, I'm going to go over the side and do a little work here. We have 90. Let's even. So 90 divided by 2 is 45. Now, obviously 45 you could divide by 3 or 5. So let's just say, let's divide it by 5. And we get 9. And then 9 can be broken down to 3 and 3. So in other words, instead of writing 90, I'm going to write 2 times 5 times 3 times 3. All right, let's do the 72 on the bottom now. 72. Well, you can divide that by 2 and get 36. Now, you could obviously break that into prime numbers, but 36 is a perfect square. So anytime we find a perfect square, I'm just going to break that into 6 and 6. So in other words, we can break 72 down to 2 times 6 times 6. Okay, so now we're going to use that pair system. We have a pair of 3s here and a pair of 6s. So we're going to simplify the radicals. So now I'm going to write this as 4 times 3 and leave the 2 and 5 underneath the radical symbol. And I'm going to leave the 2 underneath the bottom and take out a 6. 3 times 6 and leave the 2. And we get rid of the pairs. All right, well, to finish it up, look out front. We can definitely simplify out front now. 3 divided by 3 cancels and makes 1. 4 and 6, we can divide those both by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. And the 2 here and the 2 here, since they're both under the radical symbol, we can divide both of those. But you can only divide the ones underneath with the other ones underneath. All right, so when we clean this all up, what are we left with? A 2 and a root 5 on top and square root of 3 on the bottom. And that's as simplified as this gets. Okay, so that's the end of today's lesson. Try the homework questions on the assignment. Show your steps. Don't just write final answers, okay? No matter how easy you find it or challenging, you need to still write out some steps if you want to receive full credit for your work. If you only write final answers, you aren't going to get any credit.